This video is about API Bench, an exciting free open source tool to test and track your API response times for your REST APIs to determine consistency and reliability across versions, more importantly, and uncover performance issues sooner. And this is a re-recording of an event we hosted with the Developer Safe Place community created by David Adams. In the live event, David actually kicked us off by talking about the Developer Safe Place. I won't repeat all that here, but go check it out on Discord. The Developer Safe Place is a worthwhile community of software developers discussing software development topics and other issues of life as a developer. It's a pretty great place. And I'm Colin Breckles with Castlebreck. Today's speaker is Bjorn Butner. Bjorn is a passionate software developer with 14 years of experience working in development teams ranging from under 10 people up to about 90 people. He is mostly focused on web development and performance. Bjorn's the creator of API Bench and an active and valued member of the Developer Safe Place community. So let's get right into it.
Thank you very much, Colin. Let's get started.
So Bjorn, will you tell us why you created API Bench?
Yes, of course. It all started with a challenge. We had a huge code base with about 3 to 4 million lines of code. That code base was homegrown, so there were unexpected side effects to any change that you actually did. Sometimes this were just mere seconds of loading time, but in other cases we had a minute of loading time increases in some rare cases at least. The issue there was that it was hard to discover with the amount of concurrent users we could provide for testing. The challenge there was getting any performance metrics that was valuable at all. We went ahead and integrated some performance testing there to capture the response times of the APIs that were powering that application. Most of them were RESTful or very similar to RESTful APIs. And I started other open source tools, but they developed issues in scaling. So for example, it was hard to add additional developers to the testing in code. It was because there was a lack of a type system and the documentation was often not very easy to grasp.
So you explained that you started with other open source projects and created wrappers around them.
Yeah, exactly. It was a sort of not reinventing a wheel when it already existed. So the first goal in my case was making it easier to deal with the API that those tools provided to other libraries or applications using them. The wrapper grew. It changed route definitions. It handled framework, resulted in fast development, but it had a huge drawback, and that is the documentation that was already not up to the standards I would have liked it to be, was non-existent for this new kind of framework for testing. So scaling went bad, even worse than it was before in a way. And well, as a small side effect, I was basing it on JavaScript, so it was typeless, which made it hard to introduce new people to it because there was less support from any kind of tooling.
So that spawned the creation of API Bench itself.
Yeah, it was originally a small experiment consisting of a single file that measured response times of a single request endpoint, and it was written in TypeScript from the get-go. It was a complete rewrite, so no code was reused, which made it a lot simpler to handle. It has a similar interface, since the interface that got developed based on that wrapper was very useful and pretty readable. And the auto-completion was a huge help for faster development because TypeScript, as you might know, provides a lot of tooling around development, including, for example, automatic completions, including finding errors, very early typos. And this whole rewrite led to another nice benefit that was easier to extend because I could write it in a way that it was modular from the get-go because everything under the hood got replaced.
Nice. So will you share with us some of the key features of API Bench?
Yeah, I'd love to. So the major feature is tracking and storing response times for APIs, which can be a website as well. It doesn't make much of a difference there. The results are stored and provided in different formats according to your needs: SQL databases, JSON, CSV, HTML, and of course, if you desire it, you can have a very detailed logging on top of that, supporting some of the major logging libraries that are available in the Node.js communities by default. The benefit of storing those results was that it is an early warning system of any issue with an API. If an API got slower suddenly, you would notice with the next run that the measurements were suddenly way worse. Because the runs are repeatable, you can actually compare between different versions, because the run itself has the same metrics guiding it, and therefore it is benchmarking a response and not like a load test trying to figure out where the maximum load is and where it could fail. As I mentioned, the response times of prior benchmarks need to be compared. The capability to compare those is easiest in a database, but for more manual usage or for other tools using it, obviously JSON and CSV are provided, as well as an HTML output, so you can have a visual look if something changed dramatically. As I mentioned before, the whole framework is very configurable and has sensible defaults, so that usually you will not use more than one or two configuration variables total. But if you need it, you can change most of the behavior of the framework without writing a single line of code, and just besides the configurations that you put into the run method. A benefit from evolving from the wrapper is that the test definitions of routes, as they are called in this context, are very low on code. They use reusable middlewares by default. They provide environment variable injections with type conversions, and they easier to wrap repeated tasks in middlewares than to manually write every repetition in every test case yourself. Most of the tasks or routes less than 30 lines of code total. And I think the average length that I currently have is around 12. Recently, we went into code generation to speed up the development faster. So there is now an app skeleton generator that will generate the whole structure that is expected of the app. And there is a generator that can take an open API document, no matter if YAML or JSON, and generate basic tests from them. Those tests are also skeletons, just for the record, but they will save most of the boilerplate typing for you. So you just need to decide on which middlewares to apply in that specific case. Binaries are plug and play, as in they do exactly what you expect them to do, even if you don't throw anything else at them in regards to information. So run benchmark will run a benchmark, run load test will run a load test, generate application will generate an application skeleton, and so on. They are also documented, of course. The whole thing ends up with reusability as a huge benefit, and that not only for benchmarking, but also for related purposes, like you mentioned load testing, for example, because it is a very small behavior change for the tool. We have load testing capabilities, just a different binary with, I think, 20 lines of code on top of the normal code. And the whole things can use the exact same configuration as the benchmarking and can have some rules, some middlewares disabled, depending on your exact needs for that type of test. This also makes content testing or integration testing very easy to do with the whole tool, which is a side effect and leads to, well, one tool instead of 3 different tools in that case.
Very cool.
Yeah, one of the newest nice features is that the framework is multilingual. That is actually thanks to David, who introduced me to the idea that it could be beneficial. Currently, English, German, and Spanish are supported, but contributions of other languages desired and relatively easy.
Nice. So you'll give us a demo at this point. What are we going to take a look at in this demo?
In this demo, we'll have a look at an example API. In this case, it is the API of regress.in, which is a test API. One of the routes we're going to test is the one we're seeing here with 12 lines of test definition. It has an ID which defines what is going to be displayed to the end user. It needs to be unique so you don't confuse it. And it has a route that is being tested in the main part. The main is the request itself, using get to try to get user 23 from regress.in. Then we do have some middlewares added to the pre tag, which are preparation middlewares. They add additional content. So in this case, we add a user agent to the request so that you can identify that it is API bench and specifically which project of API bench is running that test. And we add the access token middleware. So we use an access token that we got from a different request. Additionally, we are making sure that there is a validation happening in the post middlewares. This is specifically a validation middleware, but you can also do post processing. In this case, we're just checking that we get status for the non-existing user.
All right. So you give us a live code demo.
Yes. So this is just my IDE. In this case, it's WebStorm, but I've had a lot of contributors using other IDEs as well, and the majority of API Bench has been written in NetBeans, for example, which is also free. We are going to have a look at the example of regress.in, which is exactly here.
So any IDE will work, right?
Yeah, any IDE. Technically, you could also just use Sublime Text, for example, as a text editor on Notepad++. You would just lose some support in creating the structure and routes. Just so we see it here, the whole thing is slightly bigger than what we were showing before. It has a couple more routes, just so we get a bit more results. So it is visible what it does if you have, let's say, 30, 40 rounds in one project. And it has a before, which is doing a login. I'm just going to run it out of the package JSON now. And we will see the output down here in a couple seconds. These are not IPs, obviously. This is just the German formatting for thousands separators, because I'm on a German system here. So if you're from any English-speaking country, just exchange comma and dot. It's the same meaning then. As you can see, we did a total of 36 requests against any of those endpoints. We have some errors here in the single user not found, which I will explain in a second. This is just for example purposes. And we obviously have all the measurements. They are in nanoseconds by default, but can be adjusted with existing tools to, for example, measure in seconds or milliseconds, depending on your needs. So looking at the 36 errors here, there is more outputs than just that line table, which will all give you an idea of what is happening. And I will show you what it looks like right away. So here in the CSV, you can already see the error. 36 times the response time was above 1 nanosecond. Obviously, 1 nanosecond is not a time in which any API will answer. So this is on purpose. You also have all the other data that you saw before. And the same goes for an HTML file, which you can easily send by mail, for example, or a JSON file, which you can use for further processing. I just reformatted it so it is easier to see for you. By default, because it's meant for machines, it's not formatted, so it's a bit smaller. So I will now show why the nanosecond error was found. You can see I have this test edited, that's why it's blue. And there is one additional, or actually there are two additional features on this test. We have a max time validator. The accent means it is part of the core framework. It's just a shortcut to putting the absolute file path there. And this max time validator uses the max duration that is defined up here, currently set to 1 nanosecond. To prove that that is not completely useless, you can obviously set it to something else, save that and run that, just so you can see the result again. And the idea there is, oh, it's still too slow, the miscount. Yeah, I miscounted 1 0 to few. And the idea behind that is that you use max time to define the maximum time an API, I can't count today, I guess, it has to respond to a request. Yeah, okay. Now we have enough zeros. So usually you define your max duration based on service level agreements, for example. If your API has a defined maximum response time of 200 milliseconds, you would put 200 milliseconds there. Or if you know that on average it responds in 82 milliseconds, you might put 100 milliseconds there to error out if there is a noticeable change. With the standard deviations that we have in the last two columns here, you can also see how stable that API is in terms of response times. So looking at the top one, create user, it differs a lot between the requests, while looking at the bottom one, it is for the single user return relatively stable in that case. The split between 80 and 100% here is also a way of trying to show the difference between rare occurrences, like by chance a database not responding in time, for example, because it was doing something else in the background, and the usual response times. So cutting off the top and bottom 10%, that is the 80% central range, removes a lot of the hard to explain and rare occurrences that don't usually have to deal with. The closer the two are together, the more stable your API is, by the way. Yeah, I think that should do for a presentation for now.
Bjorn, you mentioned you've been using this in production since 2020. Can you tell us about your production use of the tool and the benefits you've observed from using it?
Yeah, happily. So the number one task at my previous work or prior workplace was running or having the tool run a couple times a day, 3 times usually, against 3 different systems to have an early warning if the code on those systems did any major changes to the performance outputs. That provided an early warning sign. Usually that got us across all products 1 to 2 issues per week that were identified early on and fixed before they even hit production. So most issues were found way before production and somewhere before the regression tests even. So they didn't make it there. Currently at my current workplace, we are also using it for API integration tests, which are going to be supported better in 2.7 to make it even easier with configuring them between the different modes. So that is an additional feature that is coming with 2.7 because it is just a tiny addition to the code base. And in my opinion, a huge value because you can reuse the same tool for 3 different things then.
That's great work, Bjorn. And you had told me some of your plans, but can you tell the audience what you have on the roadmap for API Bench?
Yes, of course. You can, of course, always have a look at the milestones on GitHub, but general plans are to support more SQL databases, first foremost of some PostgreSQL, then expanding the documentation, which is being worked on as we speak by some of the contributors who joined recently. Adding in more translations to make it even easier to use it for people who might not be fluent in English. It's very simple to help. It's YAML files that are usually 1 level deep, so they look more like key double colon value than anything else. So if you speak anything but English, German, or Spanish, or want to improve those translations, feel free to help. Your help is highly appreciated. What is coming a bit longer term away is version 3.0, which will refactor all the binaries, because the binaries currently are still based on the version 1.0 options for configurations we had, and they are hard to expand without making them extremely complicated to use. So there will be an introduction of a new binary that will handle all the commands in a more easy to use fashion by using options instead of arguments mostly. And with 3.0, which is at least a year away, we will then deprecate the old binaries and remove them.
Nice. And we'll go through some of the questions that we had. So one of the things that was asked about is how easy is it to set this up?
This can run on pretty much any machine and just needs Node itself and npm to run. So setting that up is just npx with the package name and the installer. It's documented on the website. So you have it set up in one command and you're done.
Okay, so setup's easy. Moving on from there, how much knowledge do I need to develop tests with it?
The intention is to make it easy for both QA and junior devs, especially, because those are the groups that have the hardest time with a lot of tools, as far as I can tell. So it is very easy to develop the tests. It is supported by TypeScript's interfaces, and obviously it's also documented. Most people I have set to try and write a test wrote that in their second or third try latest, completely functional.
Okay, beautiful. And the next question is it's open source, but which license is it using?
I have a liking for the MIT license because I don't want to force people to do things they don't want to do, like some other licenses do. So it is free to use for everyone. You can use it for commercial things, and you can also change it pretty much in any way, shape, or form you want to.
Okay, great. And we were asked, how much time do I need to test it out?
Uh, there is a quick start guide that would take on average 5 to 10 minutes to test it out on the website. It's 5 commands total. Most of the 5 to 10 minutes is installing packages, depending on your internet connection. And there are examples that are ready to be used, which just need a clone and npm install, like the one we used for the demo earlier, which is an effort of even less time usually. Again, depends a bit on your network connection because of the npm packages.
Okay. And people were asking what support options are available.
So the most important support option is based on GitHub. Issues, if you have any bugs, usually get an answer within 24 hours. My goal is to answer everything within 48 hours. You have GitHub discussions where you can ask longer form questions. They also get answered very quickly. Maybe not in 48 hours if it's a bit more complicated, but you'll also just be looking at a short term there. Additionally, if you're not a GitHub person, there is a group on LinkedIn, which is also linked on the website by now, where you can ask your questions and get support at about the same speed. And if you need more, we can talk about that as well.
Okay. And the next one was what is different versus other tools to test load or stress?
So most other tools are testing the maximum of load or time that an API can handle something. That means load testing tries to figure out how many users can you throw at an API until it breaks. Stress testing tries to figure out how long can you throw users at an API until it breaks. The point of this tool is more along the lines of with normal user count, does the API behave as expected? So the benefit there is less for scaling the API directly, but for making sure that your current customers don't suffer from service degradations.
Okay. Is it you had explained the number of threads and the number of requests? Is that relevant to mention here? Your configuration for your tests?
Yeah, the number of threads and the number of repetitions is relevant. You want, depending on the stability of your API response, you need some number of repetition to get a good result and not just catch an exception like you would do with Lighthouse, for example, which is, by the way, a very good tool. I usually go for 100 to 1,000 requests, but you can increase or decrease that as required. Threads, on the other hand, is the number of concurrent users you have. And that is users who are pretty much spam clicking your submit buttons or things like that. For most websites, you will be fine with firing maybe 10 or 20 users at the API, but you can scale it up to a couple times your CPU count because a lot of time is just waiting for responses. So you don't need a very beefy machine to run these tests.
Nice. That's all the questions we had. Very well done. Thanks a million for sharing it with us. And Thank you for watching, and we'll link Bjorn's website in the notes on the video so you can see the API Bench website. We'll also link to the developer safe place in case you want to take part in the chat there. And thanks for watching. Hopefully you enjoy trying out API Bench.
And let me know how it goes. I would love feedback.
How should they give you feedback? What's the best way?
GitHub or LinkedIn.
Okay, excellent. Thanks a million. Have a great day, everybody.
Bye.